All right, this is part 3 of the jeweler problem, and this assumes that you have watched some of the videos on solving systems of equations by graphing, by substitution, and by elimination. So if you haven't seen those yet, you probably want to stop this one, go back and watch those, and then come back to this. So here's the jeweler problem we've been working on. We figured out in part 1 how to take that problem and write it in the form of two equations in standard form. In part 2, we looked at how to take those equations and graph them. And now in part 3, what we're trying to do is figure out where do those intersect. Now, by looking at the graph, it looks like it's about 120 for x and 40 for y. We're going to look today at how to figure that out for sure. So we start with our system of equations, and we can use a substitution method or an elimination method here. And in this particular situation, the fact that we have 5x in both equations means this is perfectly set up for an easy elimination method. What we're going to do, multiply that second equation by -1, and now we've got a 5x on the first equation and a -5 in the second equation. When we go ahead and put those together, we add the like terms, so 5x and -5x gives us 0x, and that's what we want. We want to get rid of either the x's or the y's. The 15y plus the -3y gives us 12y. 1200 take away 720 gives us 480. So the x's are gone. We just have 12y equals 480. We divide both sides by 12. We find out that y does indeed equal 40. Now what we've got to do is plug that y back into our equations to figure out what x is. So we've got these two equations, and I've got to plug 40 back in for y. Well, do I want to put 40 with 15y or 40 with 3y? Well, 3 is going to be easier to work with, so I'm going to use that second equation, 5x plus 3y equals 720. Replace the y with 40, so we've got 3 times 40 instead of 3y. Well, 3 times 40 is 120, so we've got 5x plus 120 equals 720. We subtract 120 from both sides, we get 5x equals 600. Divide both sides by 5, we get x equals 120. So, by using algebra, we figured out that the solution really is 120 and 40. But remember from the graphing video that graphing will get you close. It won't always get you exact, especially if the answer involves fractions or decimals. If it's not a whole number, it can be really tough to tell. Also, a lot of these story problems involve very large numbers, so that we're not going by ones for every line on our graph, but like this one, we're going by tens or maybe even, hundreds, depending on what the units of that problem are. So what you're going to want to do is use algebra to figure it out. For the farmer problem, you're going to take two equations at a time, and you've got 3 different combinations, which means you're going to have to do this 3 times for each problem. You're going to come up with 3 different answers. For the farmer problem, 3 different answers. For the baker problem, 3 different answers. For the toy maker problem, they're all going to be these XY combinations, these ordered pairs, just like we saw with the 120, 40 for the jeweler problem. Now, what we're going to look at in the last part is how to figure out which of those 3 solutions is the best one that's going to get the farmer, the baker, the toy maker as much money as possible, and also which of those solutions aren't possible at all. That's what we're going to come up with in part 4.